Hello, Space Lab. I am Sean Carroll here at the California Institute of Technology, where I'm a theoretical physicist and the author of From Eternity to Here, The Quest for the Ultimate Theory of Time. And I'm here to answer your questions. The first question is, if you would travel at 99.9% the speed of light, what would things look like? And is it possible that you could invent something like warp drive that would let you go faster than the speed of light? And I love how specific this question is. 99.9% the speed of light makes me think that whoever asked the question has some sort of invention in mind that would let us do this. It's far beyond what the spaceships we can build right now, but you never know. It's just a technology challenge. And the answer is really, the world wouldn't look that different. There is, of course, what we call the Doppler effect. If you're moving in the direction of something, the light that gets to you coming from that direction is squeezed together. The wavelengths, no matter how long they are relatively shorter from your point of view since you're moving toward them as you look. So all of the red light you see is what we call blue shifted. The blue light is squeezed to the ultraviolet and so on. Now 99.9% the speed of light is a very, very fast speed, so this Doppler effect, this blue shifting, is quite severe. You would have to worry about the amount of radiation that you were looking at. The things that are ordinarily ultraviolet would be X-rays to you, so you better have some protection in front of you. And also, just because the signals that are coming from you are compressed together, it looks to you like the things in front of you are moving faster than they would otherwise. Likewise, the things behind you, those are redshifted, and those look like they move more slowly. Now that's all 99.9%, but it's not faster than the speed of light. The idea of warp drive is something that physicists have absolutely thought about. In what we call Einstein's special theory of relativity, it is simply impossible. That was his 1905 theory about space and time being together. But then in 1916, Einstein said that space and time can be warped. So we realized more recently that you can imagine warping space-time in a little bubble around you and have that bubble move in such a way that to an outside observer it looks like you're moving faster than the speed of light. However, it looks, we're not sure, but it looks like this is not actually possible in the real world. To make this happen would require tremendous amounts of energy and some negative amounts of energy. So you would need an enormous space-time warping field around you, and we don't know how to make the kind of negative energy that it would require. So the smart money is that there is no warp drive in the real laws of physics, but we don't yet have a proof. We're working on it. You should check back to see where things go. The next question is, if you did travel faster than the speed of light, would you be able to visit the past? Or if an object were moving faster than the speed of light, would it look like it was in the past? And this is a great question because this goes right to the heart of Einstein's way of looking at space and time versus Newton's way of looking at space and time. Before Einstein came along, Isaac Newton had laid down the law about space and time. They were both fixed, separate, and absolute. And what that means is that if you know that it's 2 p.m. right here, right now, you can say it is also 2 p.m. on Alpha Centauri, 4 light years away. It is also 2 p.m. in the Andromeda Galaxy, and so forth. That's Newton's way of looking at the world, but then Einstein comes along and says there's no such thing as what time it is right now in some faraway place. It's not that there's no such thing, it's more that it depends on who is asking the question. So to you, there's something called 2 p.m. on Alpha Centauri, but to somebody else moving at some speed relative to you, what counts as 2 p.m. on Alpha Centauri is completely different. And what that means is if you could travel faster than light in Einstein's universe, and he says you can't, and he's probably right, you probably can't, but if you could, imagine you said, I was able to move so fast that I got to Alpha Centauri 5 minutes from now. It only takes me 5 minutes to get there. What that means is that from someone else's point of view, you went from here now to Alpha Centauri sometime before you left, sometime in the past. So according to Einstein, if he has the last word, and we're never sure about that, if he has the last word, then the ability to go faster than the speed of light is the same as the ability to go backwards in time. You could go faster than the speed of light and come back, and you could come back before you left. Now, we don't think that there's anything that actually does that in the universe. We don't think that there are people or objects that actually do that. If there were, not only would it look like things were moving backward in time, but everything we know about causality, cause and effect, the past versus the future, this would all get jumbled together in a way that doesn't really make sense to us. So we should be thankful that Einstein says there is a speed limit on the universe. And the last question is there a timeless zone in the universe? This is an intriguing question because it's not absolutely clear what it would mean to have a timeless zone in the universe. It makes you think about what is time, what is the definition, and what would it mean to not have it. So the simplest way to think about time is that it's a label. It's a label on the different moments in the history of the universe. Our universe is like a film with different frames in the film strip, or a book with different pages. There's stuff in the universe scattered throughout space, and that stuff scattered throughout space happens over and over again, with everything slightly in a different position than it was just the time before. And the time is just a label. It's just like the page number in the book or the frame number in the film. So a timeless zone in the universe would be a place where there were no different moments, where the universe didn't happen over and over again. There was just one configuration of stuff forever. But if you think about it, what if you sort of visited that timeless zone in the universe? We have some intuitive science fiction-y picture that everything would slow down and then stop or something like that. But the truth is, you could never get there to the timeless zone, because as you approached, if you try to reach your hand in, your hand would stop moving. That's what it would mean to be timeless. You could never see the timeless zone in the universe because no light could ever come from it, because it takes time for light to travel. So our best guess right now is no, there are no timeless zones in the universe, but we keep an open mind. That's what makes theoretical physics and cosmology so much fun. Thanks for all your great questions. If you have any more questions for the next expert, please leave them in the comments below.